In the last lesson, we saw how to declare and initialize arrays. So in this lesson, we're going to learn how to access array elements, and we'll see how to initialize an array that's been declared but not initialized. We'll kind of combine those two purposes. So let's start off by creating an array. We'll use the same array we used in the last lesson, or one of them, numbers, and we'll set its size to 10. And having done that, it's really not a bad idea to get in the habit of using a variable, and actually not even a variable, a final or constant for the size of the array or the number of elements in the array. So here I'm going to create a variable size, a final, and set the array to that. I'll explain later why it's not a bad idea to do it this way. Now that we've declared the size, we're ready to access the elements and initialize each element to a value. So we'll start out with 0, I less than size. This is one reason why you want to use a variable here. It's a lot easier to keep track of the variable than try to keep track of a number. And the way we access array elements is via subscript notation, which means an open bracket followed by the array element you want. In this case, we're going through the array from I0 to I9 and assign elements, so we're going to use I inside the subscript or the brackets, and we'll set it to I plus 1 because we want the elements to be 1 through 10. So I normally use the term subscript notation to refer to bracket number bracket, and I'll say numbers sub I, meaning numbers bracket I close bracket. So that's how we access the elements. We can loop through it again and see that our array was set up correctly using the very same loop, except this time we're going to write system out print numbers sub I plus a space so that it will have some room there. Let's save this program and let's compile it. And there you see that the array elements are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. For one last exercise in working with array element access, let's total the array. So we'll create a variable total, set it to 0. Here I'm just going to copy the loop, and then we'll change the body. Actually, we could have just copied the first part, I guess. And here we'll write total plus equal numbers sub I. And here we'll write out the total. It should be 55. Save it. I keep trying to go to the root there. There we go. Pilot. Then run it. And we see the total is 55. So we access array elements via subscript notation. Now, it's very important that you do not try to go outside the array to access an element. Let's watch what happens when I do that. That's called going out of bounds. And we'll just do it directly. We'll hit 10. Remember, the last position is 9, so 10 is beyond the end of the array. So let's save the program. Clear the screen, compile it again, and run it. And there you see we get an exception. Exceptions like this are what are called runtime errors. It wasn't a compile time error. The compiler didn't check to see that we were out of bounds. But when it tried to run the program, the Java runtime saw that we tried to go beyond position 9 to position 10, and it threw an exception. That's the term we use. We say exceptions are thrown. And this array index out of bounds exception was thrown when we tried to access numbers sub 10. Right here. Because that's beyond the upper bound of the array, meaning it's out of bounds. So that's probably the key thing to remember about arrays. You cannot go beyond the last element of the array without an exception being thrown, and the compiler catches it every time. So we use subscript notation to access elements. The first element is 0. The last element is the last position in the array, one less than the size that was declared. And I also mentioned that it's a good idea to use a final or a variable for the size. That way you can reference that variable in your program. You don't have to try to remember what the actual number is. You can call it size or AR size, some sort of mnemonic device to let you know that that variable refers to the array size. So that wraps up this lesson on array access. And in the next lesson, we're going to talk about passing arrays to functions and look at some more uses for arrays.